Hey, this side Ankush Rana. I'm currently pursuing my BSc Electronics from Acharya Narendra College. In this tutorial, you will learn how to determine the value of Boltzmann constant by studying current voltage characteristics of a forward bias diode. So, I have divided this tutorial into 5 steps. So, first we will learn how to set up the virtual lab. In the first step, we will learn the theoretical concepts required for this practical. In the second step, we will learn working formula, basically the diode equation. And then in the third step, we will look at the Multisim software which we will be using for designing our circuit. And then in the fourth step, we will look at the observation table and the graph which we will plot using MS Excel. In the fifth step, we will draw conclusion and find the value of Boltzmann constant. So let's move to the first step, which is looking at a theoretical concept. So talking about the theoretical value of Boltzmann constants, A is equal to 1.38 into 10 to the power minus 23 joule per Kelvin. Boltzmann constant give relationship between the temperature T of a particle and the equivalent theoretical energy E. So talking about the E, which is the thermal energy of the particle, is equal to K times T. At room temperature, T equals to 300 Kelvin. E, which is the energy of the particle, thermal energy of the particle, is equal to 0.02586 electron volt. Boltzmann constant is named after its 19th century Austrian discoverer Ludwig Boltzmann. So, to determine the value of Boltzmann constant using VI characteristics of forward bias PN junction. So, when the positive terminal of the battery is connected to the P side of the PN junction, and the negative terminal of the battery is connected to the N side of the PN junction, we called it as forward bias junction. This is the VI characteristics in the forward bias junction. And this is the knee voltage, the voltage after which the value of current started increasing. And that value for silicon is 0.7 volt, and for germanium that is lower, which is 0.3 volt. So this is the forward bias graph. We don't have to look upon the reverse bias because we need only forward bias graph for this for calculating the Boltzmann constant. Let's talk about the diode current equation. You must have studied this diode current equation in your semiconductor paper, and where I is equal to Is exponential QV upon NKT minus 1, where Is is the reverse saturation current. Now talking about the N is the value which can be 1 for the germanium diode. If you are using if you are trying to calculate the value of Boltzmann constant using the germanium diode, then you have to get the value of N is equal to 1, and if you are using silicon diode, then you have to keep the value of N is equal to 2. Now using some mathematics, we have taken log on this both side. And we know the basic property of formula of log, which is log A into B is equal to log A plus log B. We have used this, and we have then converted it into NT log, and this is the final equation which we have got. Now we will get this graph. We will come to know this how we have got this graph. So in this slide you see that the above equation is the equation of a straight line in the form of y equals to mx plus c, where y is the here y we know that m, where m is the slope of the curve. So slope which is coming out to be q divided by 2.303 nk time. So if we interchange this equation, we get the value of k is equal to q upon 2.303 nt into 1 upon slope. and we will learn how to calculate the slope, which slope we are talking about. First we will calculate the value of vi characteristics. We will calculate the supplied voltage, what is the value of voltage across diode and the current across diode. Then we will plot this graph and look at the vi characteristics of that graph, and then we will take the log base 10 the I, which is the value of the current at that particular voltage across diode, and then we will plot this graph. We will get this to know in the next session. So let's look at the working formula. As I told earlier that K is equal to Q upon 2.0303 NT into 1 upon slope. For silicon diode, if we are using silicon diode and where value of N is equal to 2 and at T is equal to 300 Kelvin, this is the room temperature, you will get after substituting the value of Q, which is 1.6 into 10 raised to power minus 19 coulomb, and talking about the T, which is the temperature, is given at the room temperature 300 Kelvin, and value of N for the silicon diode is equal to 2. You will get a simpler equation, which is K is equal to 11.59 into 10 to power minus 23 upon slope. And similarly, if you are calculating it using the germanium diode, then you have to substitute the value of N equal to 1, K as it remains same, and what the value of K which you will get is the simpler equation, which is 231.18 into 10 to the power minus 23 upon slope. So this is the circuital diagram, which is the voltage source here, 5 volt voltage sources. This is the potentiometer. This is the ammeter, which is calculating the current across the diode in milliampere. This is the voltmeter, which is calculating the voltage across the diode in volts. So let's move on the multisim setup. Let's shift to the multisim setup. So this is the basic circuital diagram. You can see it is the voltage meter, and this is the ammeter, and this is the diode equation. It is in the forward diode as a positive terminal of the battery is connected to the P side of the junction, and negative terminal of the battery is connected to the N type of the PN junction. Now this is the potentiometer. You must need to ground it, and let's start the simulation. Now what you need to do is, you can see here the voltage across the diode and the current across the diode. So at 0 voltage, like I have not supplied any voltage, the voltage I have get across the diode is 0.5 microampere, and the current is equal to 0. So you need to copy down this in the MS Excel. Let's what you need to do is, you need to scroll down this, like you need to increase the percentage of the voltage supply. So you can see that the voltage across this is 0.5 to 5, which is in, as I also told you earlier, it is millivolt. Now talking about the current, it is getting 1.8 to 5. So what you need to do is, you have to slowly increase the value, increase the percentage of the voltage supply, and you need to note down these values. Okay, this is all about the multisim setup. Let's move to the presentation again. So this was all about the multisim setup. Let's move to the next part of our video, which is observation table and graph. So for this purpose we will be using MS Excel. Let's shift our window to MS Excel. This is what I have told you to get the values of voltage and current, and log the formula which I have used here. You can see equal to log this the number which you write is the base, which is log base 10, and in bracket you can type the name of the cell, and here I want to find out the log of this log base 10 of this cell, which is this one. And if you want to get the name, then this is B1, and the position is 157. So I have write 157, and okay. Then talking about this is the VI graph, voltage and current graph, which I have calculated using MS Excel. This is the voltage across the diode, this is the current we get at that voltage, and this is similar to the PN junction forward diodes characteristics which we have seen in our slide. And talking about this graph, this is the graph between the voltage and the log base 10 of the current. So this is the graph what we want. Okay, now looking at this graph, look at this graph. Now we have to find out the slope of this. We know the formula, K is equal to, for I have calculated this for which silicon, and the code of that diode is 1N4001G, and this is the value of the slope. You know the formula of slope, which is y2 minus y1 upon x2 minus x1, and if you apply to any two values of this graph slope, then you will get we know the formula for that, K is equal to, which is K is the Boltzmann constant, is equal to 11.59 into 10 to power minus 23 divided by the slope. Now we have calculated the slope, which is coming out to be 8.56, and for any point you will get the slope which is around 8.6. Now you have to substitute this value of slope in this formula, and you will get the value of K, which is coming out to be 1.335 into 10 to power minus 23 joules per Kelvin. Let's move to our presentation. So we have observed all the graphs and the table, table we have created, and the graphs. Let's move to the next part of the slide. Yeah, which is the result and conclusion. So what we have observed, that the value of Boltzmann constant has been successfully determined using the current voltage characteristics of a forward bias diode. The major value of K is found to be close to the theoretical value, which is 1.38 into 10 to power minus 23 joule per Kelvin. So the value which we have got is 1.33, which is approximately equal to 1.38. Thank you for watching this tutorial.